June 1943 at the Recklin-Latz airfield in Germany at 10 a.m. The air was thick with the scent of aviation fuel and the quiet desperation of a regime beginning to realize its own limitations. On the tarmac sat a sight so bizarre it seemed to defy the laws of aerodynamics and common sense alike. It was a Junkers Ju-88 medium bomber, but it was not alone. Perched precariously atop its fuselage, held in place by a complex web of steel struts, was a Messerschmitt Bf-109 fighter. This was the birth of Project Beethoven, more colloquially known as the Mistel, or mistletoe. To the men watching from the hangars, it was the father and son plane, a composite weapon born from the realization that Germany lacked the heavy strategic bombers necessary to strike the heart of its enemies. The concept of a composite aircraft was not entirely new, but its application as a guided flying bomb was a radical departure from traditional warfare. In the years leading up to the conflict, experimental designs had explored the idea of using a smaller aircraft to launch a larger one, or even using a mothership to carry a mail plane across the Atlantic. But as the tide of the Second World War turned against the Third Reich, the engineers at Junkers, led by the visionary Siegfried Holzbauer, reimagined this aerial partnership. They saw a way to take aging, battle-worn airframes and turn them into the most devastating precision instruments of destruction the world had yet seen. The logic behind the Mistel was rooted in a glaring weakness of the Luftwaffe. Unlike the Allies, who possessed the four-engine B-17s and Lancasters capable of leveling cities, Germany had largely focused on tactical, short-range aviation. By the summer of 1943, the High Command was panicking. They needed a weapon that could penetrate the heavy defenses of the Soviet industrial heartland or sink the massive battleships of the British Royal Navy at Scapa Flow. The solution was to take a Ju-88, remove its cockpit and crew compartment, and replace it with a massive, nearly 4-ton shaped charge warhead. This was not just a bomb. It was a nearly 7-ton projectile capable of punching through 7 meters of reinforced concrete or the thickest naval armor. However, a bomb of this size was useless if it could not be delivered to the target with pinpoint accuracy. This is where the son part of the equation came in. The fighter perched on top would serve as the brain of the operation. The pilot sat in the fighter, controlling both aircraft simultaneously through a complex series of electrical and mechanical linkages that fed back from the lower bomber. He would fly the entire ungainly contraption to the target zone, line up his approach in a shallow dive, and then, at the critical moment, trigger a series of explosive bolts. The fighter would break away, banking sharply to safety, while the lower aircraft, now a pilotless missile, would plummet toward its destination, guided by its last set of flight commands and the sheer laws of physics. The engineering required to make this work was nothing short of miraculous for the time. The pilot had to manage the throttle of 3 different engines, the fuel consumption of 2 separate systems, and the aerodynamic drag of 2 different airframes fighting against each other. It was described by test pilots as trying to fly a multi-story building. The takeoff was particularly treacherous. With the combined weight of 2 aircraft and a massive explosive payload, the Mistel required incredibly long runways and perfect weather conditions. If one engine failed during the ascent at 11 a.m. on a practice run, the entire assembly would become a funeral pyre for the pilot trapped on top, unable to eject through the spinning props of his own aircraft and the structure below. As the development progressed, the project took on the code name Beethoven, perhaps a nod to the symphonic complexity of its operation or the sheer scale of its intended impact. It represented a shift in the Nazi war machine toward the wonder weapons, the Vergeltungswaffen, which they hoped would snatch victory from the jaws of certain defeat. But beneath the technical ingenuity lay a darker reality. The Mistel was a weapon of exhaustion. It used existing technology in a Frankenstein-like fashion because the resources to build something truly new and effective were rapidly disappearing. They were taking planes that should have been retired and turning them into kamikaze drones, minus the human sacrifice of the pilot. The genesis of the Beethoven device was not just a feat of engineering. It was a symptom of a crumbling empire. It showed a military culture that was willing to gamble everything on high-risk, low-probability strikes. While the engineers saw it as a masterpiece of integration, the strategic reality was that Germany was trying to solve a strategic deficit with a tactical gimmick. They were attempting to bridge the gap between their dwindling air superiority and the massive industrial output of their enemies, with a weapon that was as fragile as it was powerful. As we look back at these bizarre silhouettes against the German sky, we see more than just a strange footnote in aviation history. We see the final, desperate gasps of a regime that had run out of time and space. The Mistel serves as a poignant reminder of how war can drive innovation to the brink of insanity. It was a testament to human ingenuity, yes, but also to the tragedy of that ingenuity being harnessed for nothing but destruction. The father and son planes never turned the tide of the war, but they left behind a legacy of what happens when the pursuit of a silver bullet replaces sound strategic planning. They remain a haunting image of a world where the boundary between a masterwork of design and a weapon of total desperation became indistinguishably blurred. This was the beginning of a mechanical symphony played out in the clouds, where the only cresco was a final devastating impact. May 1943, at the Junkers testing facility in Dessau, the theoretical became physical, as engineers prepared to marry two distinct breeds of aircraft into a single, lethal entity. This was the moment where the Junkers Ju-88, a versatile and respected twin-engine bomber, was stripped of its dignity and its cockpit to become the muscular lower half of the Mistel. The engineers were not merely bolting one plane to another. They were attempting to fuse two separate nervous systems into one. On the assembly floor, the air was thick with the smell of hydraulic fluid and the sounds of heavy riveting as crews installed the massive R-frame struts that would support a Messerschmitt Bf 109 perched directly above the bomber's fuselage. This was the birth of a parasite, but unlike those found in nature, this host was designed to be consumed in a single, cataclysmic strike. The technical challenge was staggering. To make the Mistel a viable weapon, the pilot in the fighter had to have complete control over the bomber beneath him. This required an intricate web of electrical and mechanical linkages that bypassed the traditional flight deck of the Ju-88. Every movement of the fighter's control stick and every adjustment of the throttle had to be mirrored by the heavy servos in the bomber's wings and tail. It was a mechanical symphony where the pilot became a conductor, feeling the sluggish, heavy response of several tons of dead weight through his own flight controls. The Junkers engineers spent months perfecting the synchronization, ensuring that the rudders and elevators of both aircraft moved in perfect unison, lest the entire assembly tear itself apart mid-air. At 9 a.m. on a crisp morning, the first fully realized Mistel prototype sat on the runway, its silhouette resembling a predatory bird carrying its young. But the weight was no longer a payload of soldiers or traditional bombs. In place of the Ju-88's glass nose was the Beethoven warhead. This was a shaped charge of unprecedented proportions, weighing nearly 4 tons. Its design was based on the Monroe effect, utilizing a copper cone to focus the explosion into a hypervelocity jet of molten metal. The engineers knew that standard bombs would bounce off the thick concrete of a submarine pen or the armored deck of a battleship. The Mistel's warhead, however, was designed to punch through 7 meters of reinforced concrete. It was a precision instrument of total annihilation, turning the entire Ju-88 into a flying lance. The logistics of getting this behemoth into the sky were equally daunting. With the fighter mounted on top, the center of gravity was shifted dangerously high. During the takeoff roll at 10 a.m., the pilot had to manage 3 engines simultaneously: the 2 Jumo power plants on the Ju-88 and the single Daimler-Benz engine in his fighter. The torque was immense, threatening to pull the aircraft off the runway at every second. If the fighter's engine provided too much lift before the bomber reached takeoff speed, the struts could snap, or the entire assembly could pitch forward into a fatal nose-over. To solve this, specialized landing gear was often fitted, adding a third wheel to the Ju-88's nose to handle the crushing pressure of the combined weight. Once the Mistel was airborne, the pilot faced a different set of engineering hurdles. The aerodynamics were a nightmare of turbulence and drag. The air rushing over the bomber's fuselage would hit the fighter's wings at strange angles, causing a constant bone-shaking vibration. Fuel management also required a stroke of desperate genius. To ensure the fighter had enough fuel to return home after releasing its cargo, the engineers developed a cross-feed system. The fighter would draw its fuel from the Ju-88's massive internal tanks during the long flight toward the target, keeping its own tanks full for the solo journey back. This umbilical cord was the only thing that made the mission survivable for the pilot, yet it added another layer of complexity to an already overburdened machine, as the mission neared its climax, usually around 2 p.m. To take advantage of the high sun for visibility, the pilot would begin the separation sequence. This was the most critical phase of the engineering design. The two aircraft were held together by explosive bolts and a quick-release harness. The pilot would put the Mistel into a shallow dive, aiming the nose of the Ju-88 directly at the target. At the precise moment, he would trigger the bolts. The fighter would surge upward, suddenly liberated from its massive burden, while the Ju-88 continued its silent, ballistic glide toward the objective. It was a moment of violent divorce, where the brain of the operation abandoned the body it had commanded for hours. But for all the structural brilliance and the thousands of man-hours spent in the junkers' workshops, the Mistel remained a weapon of tragic futility. It was an engineering solution to a strategic problem that Germany could no longer solve. The Mistel required absolute air superiority to reach its target, as its slow speed and limited maneuverability made it an easy mark for Allied fighters. By the time the beast was ready for combat, the skies were no longer controlled by the Luftwaffe. The engineering was sound, the warhead was devastating, and the control systems were a triumph of integration. But the context was missing. It was a high-tech hammer being built while the house was already burning down. The legacy of the Mistel is not one of military victory, but of the terrifying heights human ingenuity can reach when pushed by the winds of desperation. It stands as a testament to a period when the line between a masterpiece of design and a weapon of total madness became indistinguishably blurred. The Junkers engineers succeeded in creating a mechanical marvel, a dual-layered aircraft that defied the laws of traditional aviation. Yet in doing so, they created a symbol of the Reich's ultimate failure. The belief that a complex machine could somehow compensate for a collapsed strategy. The Mistel remains a haunting image of the Second World War, a mechanical symphony that promised a cresco of destruction, but ed as a hollow echo in the vast, unforgiving sky. It reminds us that even the most brilliant engineering, when divorced from sound logic and tethered to a lost cause, becomes nothing more than a monument to a world that has lost its way. July 24, 1944. Over the skies of northern France, a lone pilot sits within the cramped cockpit of a Focke-Wulf 190, but he is not flying a fighter mission in the traditional sense. Beneath his landing gear, tethered by a massive tripod of steel struts, sits a pilotless Junkers 88 medium bomber, its nose replaced by a terrifying 2-ton-shaped charge of high explosives. This is the Mistel, and the procedure the pilot is about to undertake is one of the most mechanically complex and nerve-wracking maneuvers in the history of aerial warfare. To understand the Mistel is to understand the terrifying precision required to turn two distinct aircraft into a single, cohesive weapon of mass destruction. The mechanics of separation were not merely a matter of flipping a switch. They were a masterclass in aerodynamic theory applied under the most desperate of circumstances. The connection between the father and the son was achieved through a 3-point attachment system. Two main struts supported the weight of the fighter at the rear, while a single central strut at the front controlled the pitch and ensured the fighter's nose stayed level with the bomber below. This was not a passive ride for the Ju-88. The pilot in the upper cockpit had full control over the engines and control surfaces of both aircraft through a complex series of electrical linkages. As the clock struck 5:15 a.m., the pilot would begin his final approach, feeling the sluggish, heavy response of the combined airframes as they fought against the morning turbulence. The weight was immense, and the drag created by the struts made the Mistel a sitting duck for any Allied interceptors. The true mastery of this weapon system lay in the master release sequence. When the pilot reached the designated release point, usually about 2 or 3 miles from the target, he had to perform a series of actions with perfect timing. First, he would set the Ju-88's autopilot to maintain its current heading and a slight downward glide slope. This was critical because any shift in the bomber's trim after separation would the massive explosive charge wide of its mark. Then, at exactly 5:20 a.m., the pilot would initiate the mechanical separation. This was handled by explosive bolts located at the junction of the struts and the fighter's airframe. When triggered, a small pyrotechnic charge would shear the metal pins holding the two planes' theirs together. The danger at this moment was extreme. As the bolts fired, the sudden loss of several tons of mass from beneath the fighter caused the upper aircraft to jolt upward violently. Simultaneously, the aerodynamic wash from the bomber's wings could catch the fighter, potentially flipping it or causing a mid-air collision. To counter this, the pilot had to pull back on the stick and bank away in a sharp, climbing turn the moment the separation occurred. This maneuver, often practiced in the quiet hours of 3 p.m. at training grounds in Germany, was the only way to ensure the pilot survived the release. Once the umbilical cord was severed, the Ju-88 became a guided missile. The pilot would watch from his assing fighter as the bomber plummeted toward the target. If the separation had been masterfully executed, the bomber would maintain its trajectory, its engines screaming as it accelerated toward the Earth. The shaped charge in the nose was designed to penetrate the thickest steel of a battleship or the reinforced concrete of a bridge, making it a weapon of unprecedented destructive potential. However, the mechanics of separation were fraught with failure points. If an explosive bolt failed to fire, the fighter could become pinned to its dead weight, dragging both pilot and bomb into the ground. If the electrical pulse arrived a fraction of a second late, the sync between the two aircraft would be lost, and the resulting turbulence could tear the wings off the fighter. By 6 a.m., after the dust of the explosion had settled, the success of the mission often rested on whether a single fuse had functioned correctly under the immense pressure of the separation. This bizarre mechanical marriage was born of necessity, a desperate attempt to find a way for a crumbling Luftwaffe to strike back against a tide that was already overwhelming them. It required pilots to be part engineer, part daredevil, and part executioner. The Mistel was a testament to German ingenuity, but also to a profound disconnection from reality. It was a weapon that required hundreds of man-hours to assemble for a single, often missed, opportunity. The mechanics of the Mistel leave us with a haunting reflection on the nature of war and technology. It represents the point where engineering becomes an act of obsession, where the complexity of the solution begins to outweigh the logic of the conflict itself. As we look back at those silent, tethered giants in the sky, we see more than just a clever separation protocol or a powerful explosive charge. We see a civilization attempting to solve the unsolvable, trying to build a bridge to victory out of scrap metal and explosive bolts while the ground beneath them was already gone. The legacy of the Mistel is a reminder that in the final hours of a lost cause, the most brilliant minds often produce the most tragic inventions, creating machines that are magnificent in their design, but ultimately hollow in their purpose. It stands as a monument to the dangerous brilliance of a world that has replaced wisdom with mechanics, June 24, 1944, at the airbase of Saint-Dizier in occupied France. The night air was thick with the scent of high-octane fuel and the nervous energy of men who knew they were about to participate in a desperate gamble. For weeks, the Allied invasion fleet had been pouring men and steel onto the beaches of Normandy, and the German High Command was frantic for a way to break the maritime lifeline of the liberation. On this humid evening, the first operational unit of Mistel composites, belonging to the second group of Kampfgeschwader 101, taxied onto the runway. These were the strange, piggyback pairings of a small Messerschmitt fighter perched atop a pilotless Junkers Ju-88 bomber, the latter stuffed with nearly 4 tons of specialized explosives. As the engines roared at 11 p.m., the ground crews watched in silence, knowing that these ungainly contraptions represented one of the last chances to stop the tide of history. The takeoff itself was a feat of nerve-wracking precision. With the combined weight of 2 aircraft and a massive payload, the Mistel required an incredibly long runway and a pilot with a steady hand to manage the uneven centers of gravity. Once airborne, the 4 composites lumbered toward the mouth of the Seine, flying low to avoid the prying eyes of Allied radar. The plan was as simple as it was terrifying. The pilot would fly the entire assembly toward a high-value target, preferably a battleship or a heavy cruiser, and once aligned in a shallow dive, he would fire explosive bolts to separate his fighter from the bomber. The fighter would peel away and climb for safety, while the Ju-88, locked on a terminal course, would act as a massive guided missile. By the time the clock struck 1 a.m. over the English Channel, the pilots could see the horizon flickering with the distant flashes of anti-aircraft fire and the pale silhouettes of hundreds of Allied ships. The lead pilot, Unteroffizier Albert Royusch, spotted his target through the hazy moonlight. It was the HMS Nith, a river-class frigate acting as a command and control ship. As he pushed the nose of the composite into a descent, the sheer physical strain of controlling 2 airframes was immense. At the critical moment, Royusch triggered the separation. The Messerschmitt jerked upward as it was freed from the weight of its partner, and the explosive-laden Ju-88 plummeted toward the dark waters below. The impact was catastrophic. The Ju-88 struck the HMS Nith with the force of a small earthquake. While the shaped charge warhead was designed to punch through the thick armor of a battleship, its effect on the lighter frigate was devastating. The explosion killed 9 sailors and wounded nearly 30 more, causing such severe structural damage that the ship had to be towed back to England, effectively knocked out of the war. To the Luftwaffe observers, this was the proof of concept they had been waiting for. A single pilot had successfully delivered a payload that would normally require a full squadron of traditional bombers, all while remaining relatively safe from the thickest of the ship's defensive fire. However, the success of the HMS Nith was an outlier in a night defined by chaos and technical failure. Of the other 3 Mistels launched that night, one suffered a mechanical malfunction that forced the pilot to jettison the bomber prematurely into the sea. Another was intercepted by a British Mosquito night fighter before it could even reach the coast, the heavy and slow composite being an easy target for the nimble Allied hunter. The third pilot, blinded by searchlights and deafened by the roar of hundreds of anti-aircraft guns, missed his target entirely, his 4-ton bomb exploding harmlessly in the mud of the French coastline. As the sun began to rise on the morning of June 25, 1944, the reality of the Mistel's combat debut began to set in. While the weapon was undeniably powerful, it was also tragically impractical in an environment where the Allies held absolute air superiority. The Mistel was a creature of the shadows, reliant on the cover of night and the element of surprise. But by the summer of 1944, the sky over France was never truly dark for the Germans. The Allied radar networks and night fighter patrols were too dense, and the Mistel was too slow and too vulnerable during its long approach. The combat reality of the Mistel was a microcosm of the entire German war effort in its final year. It was a technological marvel, a precursor to the modern cruise missile, born from a desperate need to compensate for dwindling resources. Yet, for every ship it damaged, dozens of Mistels were destroyed on the ground or shot down before they could release their payloads. The pilots were brave, often exceptionally so, but they were being asked to fly machines that defied the laws of traditional aerial combat in a theater where the odds were already stacked against them 10-1. The strikes against the Allied invasion fleet proved that while you can engineer a miracle of physics, you cannot easily engineer a victory out of a collapsing front. The Mistel remained a phantom of the Channel, a bizarre sight that haunted the nightmares of Allied sailors, yet it never achieved the strategic breakthrough the Reich so desperately craved. It was a weapon of incredible potential that arrived in a world where potential had already been traded for the cold, hard currency of attrition. In the Mistel's legacy is not found in the ships it sank, but in the haunting image of its design. It represents the point where human ingenuity crosses the threshold into the surreal, where the terror of defeat drives a nation to weld its existing tools into strange, Frankensteinian monsters. It serves as a poignant reminder that even the most advanced technology is hollow if it is used only to delay the inevitable. The Mistel was a scream of defiance in the dark, a mechanical marvel that was ultimately drowned out by the thunder of a world that had moved past the era of the lone hero and into the age of overwhelming industrial force. It stands today as a monument to a time when brilliance was used to feed the flames of a dying cause, leaving behind nothing but the charred remains of wings and the silent echoes of a lost generation. December 1943, in the secluded planning rooms of the Luftwaffe High Command, the air grew thick with a desperate realization that conventional warfare had failed to stop the Soviet steamroller. The German leadership looked toward the horizon of the Eastern Front and saw not just an army, but an unstoppable industrial heart beating with a rhythm they could no longer match. Operation Eisenhammer, or Iron Hammer, was conceived as the ultimate antidote to this manufacturing nightmare. It was a plan so ambitious it bordered on the impossible, aiming to do with a single blow what years of scorched earth and traditional bombardment had failed to achieve. The goal was the total annihilation of the Soviet power grid, a strike intended to plunge the entire Russian war machine into a permanent frozen darkness. Engineers and strategists identified 12 massive hydroelectric and thermal power plants surrounding Moscow, Gorky, and Tula. These facilities were the nervous system of the Soviet war effort, powering the massive factory complexes that churned out T-34 tanks and Yak fighters by the thousands. The German planners knew that if these turbines were silenced, the Red Army would effectively be paralyzed, left without the fuel, steel, and ammunition required to maintain their westward momentum. However, these targets were situated hundreds of miles behind enemy lines, protected by layers of anti-aircraft fire, fighter screens, and the sheer vastness of the Russian interior. Standard bombers like the Heinkel 111 or the Junkers 88 lacked the precision to hit specific turbine holes from high altitudes, and dive bombers simply could not carry enough weight to penetrate the reinforced concrete shells of the power stations. This was where the Mistel, the bizarre father and son composite aircraft, was meant to find its dark purpose. The plan called for nearly 100 of these piggyback machines to launch a coordinated strike. It was envisioned as a surgical scalpel of unprecedented scale. By 11 p.m., on a moonless night, the formations were supposed to slip through the gaps in Soviet radar coverage, guided by specialized pathfinders using advanced radio navigation. The Mistel units would then separate over their targets, with the pilot in the upper fighter guiding the massive explosive-laden lower half directly into the heart of the generators with pinpoint accuracy. The lower Junkers 88 would be fitted with a specialized Sachs hollow charge warhead, a massive conical explosive designed specifically to punch through the thickest armor and concrete before detonating. Yet, as with so many of the Third Reich's miracle plans, the clock was ticking faster than the engineers could work. Throughout the long months of 1944, the operation was postponed time and again. First, it was a chronic lack of aviation fuel that grounded the training flights. Then, the Allied landings in Normandy forced the Luftwaffe to redirect every available fighter and bomber to the Western Front to contest the skies over France. By the time the logistics were finally in place in early 1945, the Soviet front line had moved so far west that many of the designated launch airfields in East Prussia had already been overrun by the very tanks the operation was supposed to stop. By 2 p.m. on March 20, 1945, the orders for Operation Eisenhammer were finally finalized, but the strategic reality had shifted from ambition to survival. The dream of shattering the Soviet electrical grid had evaporated, replaced by the immediate, panicked need to destroy the bridges over the Oder and Vistula rivers. The Great Iron Hammer was reduced to a desperate attempt to slow down a flood of soldiers already standing at the doorstep of the Reich. The Mistel, designed to be a strategic world changer, was relegated to a tactical nuisance, a complex weapon used to strike at river crossings in a futile effort to buy a few more days of existence. The legacy of Operation Eisenhammer and the Mistel projects is one of profound, tragic irony. It represents the pinnacle of a technological obsession that mistook complexity for effectiveness. The German High Command believed that if they could only build a smarter bomb or a more intricate delivery system, they could trans the brutal arithmetic of industrial warfare. They focused on the precision of the strike while ignoring the collapse of the foundation beneath their feet. The Mistel was a marvel of aeronautical engineering, but it was born from a philosophy that valued the machine over the reality of the conflict it was meant to solve. Today, the story of the Mistel serves as a haunting reminder of how easily the pursuit of scientific brilliance can be twisted to serve a ruinous. It highlights a moment in history where humanity's creative spirit was harnessed not to build or to heal, but to perfect the art of destruction in the name of a doomed ideology. The charred remnants of these composite aircraft, found abandoned on forgotten airfields or buried in the mud of the Oder, are silent witnesses to a generation that poured its intellect into a vacuum. They remind us that technology, no matter how revolutionary, is never a substitute for moral clarity or the harsh reality of a world that refuses to be conquered by gears and glass. The Iron Hammer did not break the Soviet machine. It merely shattered in the hands of its creators, leaving behind a legacy of ash and the urine question of what might have been achieved had such genius been used to light the world rather than plunge it into a deeper shadow. The Mistel remains a monument to the folly of the lone miracle weapon in an era of total war, a mechanical ghost echoing the desperation of a regime that chose to burn the future rather than face the present. The father and the son, the fighter and the bomb, flew together into the night, but they found only the silence of a lost cause. April 12, 1945, at the Lers airfield in northern Germany, the morning air was thick with the smell of scorched synthetic fuel and the grim realization that there was no longer a distant possibility, but a looming certainty. The Soviet Red Army was no longer a shadow on the horizon. It was a tidal wave crashing against the banks of the Oder River, the last major geographical barrier protecting the heart of the Reich. In these final, suffocating weeks of the war, the Luftwaffe turned to its most eccentric and desperate invention to stem the tide. The Mistel, that strange composite of a fighter perched atop a pilotless bomber filled with explosives, was no longer a secret project for a grand strategic strike against the Soviet industry. It was now a battlefield sledgehammer, a weapon of last resort intended to shatter the bridges that allowed the Soviet steamroller to bypass the natural defenses of the river. At 2 p.m. that afternoon, the pilots of Kampfgeschwader 200 sat in their cramped cockpits, feeling the vibration of two sets of engines fighting against the laws of physics. They were flying the Mistel II variant, a Focke-Wulf 190 fighter mated to a Junkers 88 bomber that had been stripped of its crew and packed with nearly 4 tons of specialized explosives. This was not a weapon built for dogfights or precision. It was a slow, lumbering beast that required a clear path and a steady hand. But as the pilots looked toward the eastern horizon, they knew the sky would be anything but clear. The Soviet Air Force had seized total air supremacy, and for every Mistel that took to the air, dozens of Yak and La-5 fighters were waiting to tear them apart before they could even see their targets. The mission was simple in theory, but suicidal in practice. They were to target the bridges at Kustrin and Goritz, vital arteries through which the Soviet First Belarusian Front was pumping men and steel for the final assault on Berlin. As the formations clawed for altitude, the pilots had to manage the complex controls that linked the two aircraft. The fighter pilot acted as the brain, steering the massive bomb beneath him. But the weight made the combination sluggish. If an enemy fighter appeared, the pilot faced a horrific choice: jettison the bomb prematurely to regain maneuverability and survive, or stay the course and face almost certain death. By 4:15 p.m., the first wave reached the vicinity of the Oder. The scene below was a chaotic tapestry of smoke and fire. Soviet anti-aircraft batteries had lined the riverbanks, creating a wall of lead that the Mistels had to penetrate. One pilot, realizing his heavy Ju-88 was too damaged to continue, released his payload early, watching as the massive bomber tumbled aimlessly into the marshland below, a multi-million-mark firework that achieved nothing. Others pressed on. The procedure for the attack was a nerve-wracking dive. The pilot had to point the entire composite aircraft at the bridge structure, lock the flight controls of the bomber, and then trigger the explosive bolts to separate. In that split second of separation, the fighter would jerk upward, freed from its heavy burden, while the Ju-88 would continue its descent as guided missile. On April 16th, the desperation reached its peak. The massive Soviet offensive across the Oder had begun in earnest, and the Luftwaffe launched its final significant Mistel operation. At 8 a.m., a handful of these father and son aircraft took off into a sky that was already choked with the smoke of thousands of Soviet artillery pieces. The target was the bridge at Steinau. The pilots were young, some with only a few dozen hours of flight time in the composite craft. Yet they were tasked with a feat of precision that would have challenged the most seasoned veterans. One Mistel managed to strike a bridge directly, the massive shaped charge warhead punching through the steel and concrete with a roar that could be heard for miles. For a moment, it seemed like the miracle weapon had finally delivered on its promise. But the reality of 1945 was that the Soviet Union could build bridges faster than the Germans could blow them up. Even as the smoke cleared from a successful hit, Soviet engineers were already deploying pontoon bridges nearby, often completing them within hours. The Mistel was a scalpel being used to fight a forest fire. By the time the sun set on the final sorties of KG-200, the unit had suffered devastating losses for negligible strategic gain. The pilots who returned to their bases did so with heavy hearts, knowing that their freeze had vanished into the flak-filled sky for a cause that was already buried in the rubble of their cities. The legacy of the Mistel during these final days on the Oder is one of profound, tragic irony. It represented the pinnacle of German aeronautical ingenuity, a precursor to the standoff munitions and guided bombs that would dominate modern warfare decades later. Yet, in the hands of a dying regime, it was nothing more than a mechanical ghost, a high-tech solution to a problem that had already been decided by sheer numbers and industrial might. The weapon was too complex, too late, and ultimately too isolated to change the course of history. As the last Mistels were either destroyed in combat or scuttled by their own crews to prevent capture, they left behind a haunting question about the nature of war and technology. We see in these final sorties a civilization that had focused its brilliance on the art of destruction, creating beautiful, terrifying machines that were as fragile as the ideology that birthed them. The father and the son, the fighter and the bomb, were more than just a bizarre aircraft. They were a symbol of a nation that had lost its way, attempting to fly toward a victory that had long since evaporated. The silence that followed the final explosions over the Oder was not just the silence of a lost battle, but the silence of an era of madness finally burning itself out. The Mistel remains a monument to the futility of seeking salvation in iron and explosives when the moral foundation of a cause has already turned to ash. It serves as a reminder that even the most advanced technology is powerless when it is disconnected from the reality of the human cost and the inevitable judgment of time. May 1945. At the silent and oil-stained airfields of central Germany, Allied technical intelligence teams stood in quiet bewilderment as they inspected the skeletal remains of the Mistel program. These captured machines, with their parasitic fighters perched atop hollowed-out bombers, represented the final, gasping breath of a regime that had tried to engineer its way out of an inevitable collapse. While the war in Europe was officially over, the legacy of the father and son aircraft was only beginning to whisper its secrets to the victors. This bizarre marriage of airframes was not merely a footnote of desperation, but a crude, analog blueprint for the future of global conflict. The Mistel was born from the realization that the traditional courage of a pilot was no longer enough to pierce the ironclad defenses of a modern industrial power. By 11 a.m., on the day the first Mistel units were surrendered, the engineers of the West and the East were already beginning to see past the crude bolts and the aging Junkers engines. They saw the dawn of the standoff weapon. The Mistel had attempted to solve a problem that still dominates military thinking today: how to deliver massive destructive force to a pinpoint target without sacrificing the human element in the process. It was the primitive ancestor of the cruise missile, the spiritual grandfather of the drone, and the first terrifying glimpse into a world where a pilot could pull a trigger and watch from miles away as a robot finished the job. In the decades that followed, the world would see this concept refined into the surgical precision of the modern era. At 2:15 p.m. on any given day in the 21st century, a controller half a world away might guide a projectile with the same intent that a Mistel pilot once held his control yoke over the bridges of the Oder. The technology has leaped from vacuum tubes to microprocessors, and from manual gyroscopes to satellite navigation, yet the core philosophy remains unchanged. The Mistel proved that the aircraft itself could be the ammunition, and that the man in the cockpit could be transformed from a dogfighter into a systems manager. It was a transition that stripped away the last vestiges of aerial chivalry, replacing it with the cold, calculated logic of the machine. Yet, there is a profound irony in the Mistel's legacy. It was a weapon designed to save a Reich that was already a graveyard. It was an innovation of the highest order, produced by a society that had descended into the lowest depths of moral depravity. This duality is perhaps the most important lesson the father and son planes leave behind. We often marvel at the ingenuity of the design, the complexity of the piggyback release mechanisms, and the sheer audacity of the engineers who thought they could turn an obsolete bomber into a superweapon. But we must also remember that this innovation was fueled by a fanatical refusal to accept the reality of defeat. The Mistel was a high-tech solution to a moral catastrophe, a mechanical attempt to stop the tide of history with a bigger explosion. As we look back at the grainy photographs of these strange, stacked silhouettes against a darkening European sky, we see more than just a failed experiment. We see the beginning of human-centric warfare. The Mistel represents the moment the pilot began to detach himself from the target, the moment when the act of killing became a problem of physics and telemetry rather than a face-to-face struggle. It is a reminder that every technological leap carries with it a psychological cost. The precision we enjoy today, the ability to strike with the literal push of a button, was forged in the fires of 1944 and 1945 by men who were desperate enough to try anything. The silence that now surrounds the few remaining Mistel components in museums is heavy with the weight of what might have been and what eventually became. These planes were the harbingers of a world where war is conducted in the glow of a screen, where the distance between the hunter and the hunted grows ever wider. The father and son did not save the Third Reich, but they did teach the world that the future of destruction lay in the separation of the man from the machine. They are monuments to the fact that brilliance is not the same as wisdom, and that a weapon can be a masterpiece of engineering while serving a cause that is a masterpiece of ruin. In thee, the Mistel remains a ghost in the machinery of history. It is a haunting image of a parent plane carrying its deadly child into the void, a metaphor for a generation that sacrificed its future for the sake of a shattered present. As we move further into an era of autonomous systems and invisible wars, we would do well to remember those strange composites over the Oder. They remind us that while the tools of war will always evolve toward greater precision and greater distance, the burden of the decision still rests on human shoulders. The legacy of the Mistel is not found in the metal or the fuel, but in the enduring question of whether humanity will ever outgrow its talent for building ever more perfect ways to destroy itself. The sun has long since set on the era of the piston engine and the manual release, but the shadow cast by the father and son still stretches across the horizon of modern conflict, a silent warning that the most advanced weapon is still only as righteous as the heart of the one who commands it to fly.